Hello everyone. Few days back I ran a community poll on my YouTube page and some of you wanted to have me create content around interview preparations and questions. Okay, the tips and tricks. So with that in mind, today I've planned that every Sunday I'm going to upload few questions which will help you in your interview journey. Okay, so let's start today. So the first thing first, like what sort of questions interviewer for a data science role, if you are going for a data science role, what type of questions you can expect from the interviewer? Okay. If you are, and this is primarily between 0 to 5 year, if you have experience with 0 to 5 year or you want to move into data science field, these are the sort of questions which you can expect. So broadly, it can be divided into five different categories. The first category is the technical questions. Okay, over here you will be tested on your data science concepts. So all the machine learning algorithms, deep learning, your basic statistics knowledge, linear algebra knowledge, all those things come over here in your technical questions. So this carries a major weightage. The second question would be scenario based questions. This is also related to number one over here. It is slightly different that it will not be a straightforward concept related question, but the interviewer will give you a scenario, okay, probably a real scenario from their organization, and they will ask you to provide a solution. Okay, so that is the scenario based question. The third thing which also interviewer asks is related to uh, data structures, algorithms, coding in general. It mostly will be related to Python over here, Python related coding. They will test you on SQL, NoSQL knowledge also. And in coding everything, like they can ask you pandas related questions, they can ask you NumPy related questions and various other packages also. So this will be mostly around coding, okay, and data structures. The fourth category of questions which comes is the portfolio related. What you have done till now. So it's very important that you should have a good GitHub portfolio for yourself when you are going to appear for an interview. And this way you can guide the interviewer, or you can have the flow of the interview go into your strong area, what you have done already. So ensure that you have at least three good projects in your portfolio which you are able to explain. Okay, the last thing is the behavioral questions, right? These are questions around how you will are you a team player or not. They will try to gauge that your soft skills and whether you will gel well with the team, how good a fit you are. And this, in my opinion, should be both ways, right? At the end you should also ask them question if you are a right fit to their organization or not, right? So these are essentially the five different type of questions which you can expect. And I am going to, in this series, I'm planning to cover every Sunday some of the questions, right? Okay, so today I will start with the technical questions, but I will cover all of these in weeks to come. So yeah, let's start with that then. So ultimately, I have a compilation of 50 data science interview questions with answers. I'm not sure if I will be able to do all 50 today itself, technical question. I will try to see like the rest of, I'll do it in the subsequent weeks. So the first question, which is over here, is what is naive Bayes, or rather why is, everybody knows what is naive Bayes, but why naive Bayes is referred as naive? What is so naive about it? Okay, so naive, if you know in English meaning, naive is a simpleton or a simple person, or something which we call is without, is not shrewd, right? Okay, so why a algorithm is called naive? So naive Bayes essentially is a probabilistic uh, algorithm. It's a generative algorithm, and generative versus discriminative, if you know, then it falls on the generative side. And it's based on the Bayes theorem of conditional probability. Now, why it is called naive? Now, the next question will be why it is called naive. That is the essential question. The naive in naive Bayes is because it assumes two things, not actually one, but two things. One is it assumes that all features, all columns in your data set or features or independent variables are independent of each other. They do not have a correlation among themselves. Okay, so let me repeat. It is called naive because of two assumptions. One, all the features are independent of each other. So if feature X, X1, it's not related to any other X1, X2, X3, X4, X5, right? It's independent. Second assumption which it makes, that all feature carries equal weightage. Okay, this is also important, guys, and sometimes people forget about this crucial assumption. Let's try to see with an example that what actually it means. So if you see over here, and if you recall the naive Bayes conditional probability formula, right? Let's see over here. Maybe I will. So if you see over here, P x1, x2, x1, x2 are nothing but my independent features, right? And y is my output, okay, my dependent variable. This py is called prior. This p x1, x2, the joint probability, is called the evidence, and this is called the likelihood. Okay, now I have explained this in detail in one of the video. I'll share the link and show it to you also. But let's see that why it is called naive, right? That was the original question. Okay, now let's see that. Okay, let's see. So as I was saying, these are my features, this is my output. Now with plain vanilla Bayes conditional probability, this is the formula which we would arrive at, right? To calculate what? To calculate the probability of y given x1, x2 features, right? This would be the formula. Now what naive Bayes did is that they took this particular portion, and what they did is they split it into two parts, or how many parts as the feature is, right? And they multiply it with x2 given y. Okay, so my likelihoods are split. I can only come from this stage, the joint likelihood given y, to this stage if I assume, if and only if I assume that my x1 and x2 are independent and then they are not related to each other. So this is a big assumption which naive Bayes makes, and that's why it is called naive, right? Why we are making this assumption? This makes for two reasons. One, the maths becomes simpler. Okay, with this the math becomes simpler. How the math becomes simpler? Instead of calculating the joint likelihood over here, you are calculating the independent likelihood with each features and you are multiplying it. Of course, in naive Bayes, we discount because the bottom part is constant everywhere, we discount that as well. And then we talk the log of it, like all those things I have tried to explain. But essentially, this is the transformation, or this is the assumption which we are doing. Okay, that's why it is called naive. Now, if you see, I have a playlist over here on my YouTube channel. And yeah, this is the video, right? If you see naive Bayes, this I have done in detail. I have explained it over here, that why it is called naive over here with a very good example. So if you want to see the details of it, please go ahead and explore that, right? But essentially, because of the two assumptions, one is the features are independent and the features are equally weighted, right? So as I was saying over here, from this it gets transformed to this. That's why we call it naive. Okay, I hope friends this is clear. If this is not clear, let me know in the comments and I will try to answer any of your questions which you may have. Okay.